All right, guys, welcome to part 1 of the topic 11B test review. Again, this is part 1 of the video, so if you need to see the second half of this review, please refer to part 2 of this video. So let's get started. Problems 1 and 2 are asking us, is the relationship between the variables a direct variation, an inverse variation, or neither? And if it is a direct or inverse variation, we need to write a function to model this, okay? So if we look here at our x values, you notice we're going from -9 to -7 to -2 to -1. So this is increasing, okay? But if we look at our y values, we're going from 36 to 28 to 8 to 4. We're actually decreasing. And so, since they're going in opposite directions, we're going to check for inverse variation. To check for inverse variation, we're going to use the equation k equals x times y. All right, for inverse, it's x times y. And so what I'm going to do is we're going to multiply x and y together on each of these. So if we multiply 36 times -9, we get -324. So let's see what we get when we do 28 and 7. So 28 times -7, we get -196. Now, these are not the same number. Remember, this k is a constant. So since this is not a constant value, this is not an inverse variation. And since they're going in opposite directions, we're not going to test for direct variation. So this is neither. Okay, this is neither direct nor inverse. Looking at the next one, we're going to do the same thing. X, we're going 9, 11, 13, 15. We are increasing. Y, we're going from -17 to -1 to 6. This is also increasing. So we're going to use k equals y over x because we're going to check for direct variation this time. So I'm going to do -17, excuse me, over 9. So -17 divided by 9. And I get, we'll round that to -1.9. If I do -1 divided by 11, I get -0.09. So once again, these numbers are not the same, so this is neither. Okay. But keep in mind, if we were to write an inverse variation, we would write that as y equals k over x. And if we did have a direct variation, we would write that as y equals k times x. So keep these two equations in mind in case you happen to come across a direct or inverse variation. Looking at number 3, it says a soccer team is collecting money to buy their coach a present. The table represents the cost per person of the gift compared to the number of people contributing. What function models the data, and how much per person will it cost if 40 players contribute? So looking here, we're going from 5 to 8 to 15 to 20. We are going up. All right, we'll call players X, and we'll call cost Y. And you notice the cost per player is decreasing. So we're going to do K equals X times Y. So let's do 5 times 40. 5 times 40. And we get 200. 8 times 25, also 200. And so, since this is a real-life situation, it's safe to assume that these are all going to be about 200 or close. Remember, with real-life data, you're not going to get exactly on the dot, but it's going to be close enough to where we can assume our k is 200. So we'll assume k is 200. So our equation, since this is inverse variation, is going to be y equals, it's k over x. So in this case, 200 over x. Now the situation it's giving us is assuming all 40 players. And so players is our x. We used in for our x value. So we're going to say y equals 200 over 40. So 200 over 40. And we get 5. So the cost per person will be $5 if all 40 players contribute. Okay. Now moving on to number 4. For this one, we're finding our least common multiple, our LCM, of x squared minus 7x plus 6 and x squared plus 3x minus 4. So to find our LCM, we have to first start by factoring both of these trinomials. So since I have an a value of 1 on both of these, I can use a t-chart to factor both of these. So to factor the first one, I'm going to factor 6, looking for a sum of negative 7. So I have factors 1 and 6, 2 and 3. But since we need to add to be a negative, I'm going to make both negative. And so when I make them both negative, the pair that adds to be negative 7 is negative 1 and negative 6. So this one, we're going to have x minus 6 and x minus 1. And now let's factor the other guy. So this one, we're factoring a negative 4, looking for a sum of a positive 3. So my factors of 4 are 1 and 4, and then 2 and 2. I'm looking for a positive sum, so the negative needs to be on the smaller number. And I'm going to use negative 1 and 4 as my factors. So this becomes x minus 1 and x plus 4. Now looking at my two sets of factors, first, what they have in common is they have an x minus 1, so I'll go ahead and write that down first. And then looking at this one over here, it has the x minus 6, so we need to bring him down. And then on this side, it has the x plus 4, so we'll bring him down as well. So my least common multiple for these two is going to be x minus 1, x minus 6, and x plus 4. Moving on, we're going to do 5, 6, and 7. So for these, it's asking us to simplify the sum. So remember, when you're simplifying a sum or a difference, which we'll do differences here in a minute, but if you're going to simplify these, remember, we need to start by factoring. Okay, and we need to factor especially the denominators to find our least common denominator, but also we might need to factor the numerators to cancel stuff out. Looking at number 5, my first denominator, there's nothing to factor there. M plus 9 doesn't become anything. M squared minus 81, however, that is an example of a difference of two squares. So M squared minus 81 is going to become M plus 9 and M minus 9. So for these two, my least common denominator is going to be M plus 9, because that's what they have in common, and then M minus 9. So looking at my two denominators, this first fraction here is missing that M minus 9 in its denominator. So we're going to multiply it by M minus 9 over M minus 9. And so we're going to end up with, excuse me, that denominator is now going to be M minus 9 and M plus 9. And we're going to multiply the 4 by the M minus 9. So we're going to end up with 4M minus, excuse me, 36 plus, and this fraction right here, it already has our least common denominator, so we can just write it as 5 over M minus 9, M plus 9. We don't need to change anything there. So combine our like terms, we're going to end up with 4M minus negative 36, and 5 is negative 31 over M minus 9 and M plus 9. Now, we would need to, normally we would want to try to simplify this by factoring and then canceling out any like terms, but 4M minus 31 cannot be factored, so we are just going to be left with this as our answer. Moving on to number 6, let's switch colors. We'll do this one in green. So for number 6, since I have a trinomial in the numerator, I want to go ahead and try to factor him as well. And the reason we want to do that is because if there's any like terms between this numerator and denominator, I can go ahead and cancel it out and not have to deal with it for my least common denominator. So a squared plus 7a plus 10, we can go ahead and do a chi chart to factor him. So factors of 10, that equals 7. That's going to be 2 and 5. So I'm going to go ahead and rewrite this as a plus 2 and a plus 5 over, and we're going to do the same thing with this one. We're factoring negative 15 for a sum of 2, and that's going to be a positive 5 and a negative 3. So we're going to say a minus 3, a plus 5, plus, and this, we can't factor him at all. There's nothing to do there, so we'll just rewrite it as 10 over a minus 3. Now you notice we have an a plus 5 on top and bottom, so we can go ahead and cancel that out before we deal with our least common denominator. So that can just completely go away. And now, if you look at what you have left in your denominator, our denominators are now the same. We don't have to manipulate our denominators now that we have canceled out the a plus 5. So we can just go ahead and combine like terms. We can combine the a plus 2 and the 10, and we're going to end up with a plus 12 over a minus 3. So again, keep this trick in mind. Sometimes if you can factor that numerator, try to factor it as well so that way you can cancel out some like terms. All right, let's switch colors one more time. We'll go to blue and we will do number 7. Now number 7 looks a little more complicated because we're going to have to factor a whole lot of things, but that's okay. Again, we can possibly cancel some stuff out. So first, I'm going to factor this first fraction, both numerator and denominator. So on the numerator, we're going to factor negative 30. We're looking for a sum of 1 plus d. That is a 1d. Excuse me. And so that is going to be 6. Oh, excuse me. Let's try that again. The pen got away from me a little bit. Try that again. That is going to be a 6 and a negative 5. So I'm going to go ahead and rewrite it down here. That is going to be d plus 6 and d minus 5 over, and we're going to do the same thing with the denominator. We're factoring a negative 40, looking for a sum of 3. And so that is going to be a positive 8 and a negative 5. So we're going to do d plus 8 d minus 5 plus, and now we're going to do the same thing with this second fraction. We're going to factor 48 for a sum of 14, and that's going to be 8 and 6. So d plus 8 d plus 6. Now looking at my denominator, it's a negative 48 and a negative 2, so that's going to be negative 8 and positive 6. So d minus 8 and d plus 6. Now this one's nice. We're going to be able to cancel out the d minus 5, cancel out the d plus 6. So really what we're dealing with is d plus 6 over d plus 8. And we're trying to combine it with d plus 8 over d minus 8. We are still going to have to find a least common denominator because these two denominators we're left with are not the same, which is okay. And so my least common denominator is going to just be d plus 8, d minus 8. So this denominator is missing d plus 8, so we're going to multiply by d plus 8 over d plus 8. And this denominator is missing d minus 8, so we're going to multiply by d minus 8 over d minus 8. And so we're going to equal, both of these fractions are going to have d plus 8, d minus 8. Ooh, I'm going to run out of room here, that's okay. So d plus 6, d minus 8, we would just FOIL those to combine them together. And we're going to get d squared minus 2d minus 48. And we're adding that to, excuse me, again, d plus 8, d minus 8. D plus 8 times d plus 8, that's d squared, plus 16d plus 64. And so we're going to combine these together now. And so we have d squared plus d squared, so we're going to end up with 2d squared. negative 2d plus 16d is going to be plus 14d. And then negative 48 plus 64, I'm not going to do that in my head. So 64 minus 48. So plus 16 over d plus 8, d minus 8. And so real quick, let's just double check. If we were to multiply that 2 over, we would get 16 times 2 is 32. So let's just double check real quick, see if 32 has any factors that add to be 14. So factors of 32, 1 and 32, 2 and 16, 4 and 8. So none of these factors add to be 14. So even though it looks factorable, we are stuck right here. So it's always good to check like we did here, but in this case we can't do anything. And so our final answer is going to be 2d squared plus 14d plus 16 over d plus 8d minus 8. That is going to conclude part 1 of this video. And so if you need to see anything from number 8 to the end, please refer to part 2 of this video. Have a great